hey, today we're going to talk about 8.8. There's some steps for solving radical equations. We're going to get into it with example number 1. Again, we're live streaming period 10. So if for some reason you don't feel comfortable being on here, you can always ask a question at the very end. Otherwise, if you have questions throughout, please feel free to ask, because I'm sure that somebody at home later on watching this video will have the same question in their head. All right. The biggest thing whenever we're solving radicals is we want to make sure that we can either get the radical to a place where we can square it or cube it or do whatever to eliminate it. So for example, in the first problem that we have here, I can move that 4 over first. So like, because it's multiplication, I can divide everything by 4, get the square root of 2x plus 1 equals 3. And then from there, I can square my problem. Now, this isn't always going to be the case when we have addition and subtraction, but with multiplication, we can definitely divide first and then square. Question for you. The square root of a square leaves us with what? Like in this, like the square root of 2x plus 1. When I square it, what happens? Yeah. Bella.
I think you just get 2x plus 1.
Yeah, you get 2x plus 1. Those cancel each other out. So you get 2x plus 1 is equal to 9. Solve it. So subtract 1, you get 8. Divide by 2, you get 4. There is no, I'm not going to make you do anything with domain. Okay, that's a little bit crazy and above Algebra 2 with this type of with these types of problems. I do want to let you know, though, that there is a way to check your work. Plug it back in. So if you want to check your work, you don't have to check your work, but it's good practice. You can always plug that answer back into your equation and then solve it out. So like square root of 8 plus 1 is 12. 4 square root of 9. 4 times 3. And then from there, I think we know. Bam. That's good. Okay. Questions at all on example number 1? All right. So again, because this is a live recording, you can always pause it if you're watching the video. But example number 2, okay? Oh. If you look at example number 2, how could I start the problem? How could I eliminate the cubes? Yep. Cube it. Yeah, you cube it. How do you get rid of cube root? Cube it. So these will cancel. So I'm left with 9x plus 1 equals 11 plus 8x. I'm going to subtract 8x from both sides. X plus 1 equals 11. Subtract 1. And x is equal to 10. Okay. So this concludes the easy problems. No, I'm kidding. Now time to go into something that's just not necessarily difficult, but it's a little more involved. Like how I worded that, I didn't say it was difficult. It's just a little more involved as to what we're doing. Okay. So, example number 3. We have a radical on each side of our problem. We want to make sure when we have these types of situations that 1, a radical is indeed on both sides, and then 2, one of those radicals is at least by itself. So when we square everything, it'll eliminate it. What I mean by that is, in this type of situation, if I square both sides, this left side here, these are going to cancel out, and I'll be left with x minus 1. On the other side, I take you to a separate example problem that's a little simpler. What is 2 squared? 4. How'd you get it? 2 times 2. So notice how I wrote 2 twice? I also have to write the square root of x plus 1 minus 1 twice. This is where I have to use FOIL. Dun 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 dun. Dun 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 dun. Okay.
I have a question.
Yeah.
So you accuse it. So why doesn't the radical get? Like why doesn't it get rid of the radical on the right side?
Good question. Okay. So why didn't it just get rid of, like, you mean the x plus 1
Yeah.
on the, okay. So let me put it into this perspective here. How do you solve that? How do you solve x plus 3 squared?
When you like do it, remember it?
You do what?
The radical thing. You have to get rid of it.
No. Just how do you solve that? What do you have to do?
Oh, you do x plus 3 2 times.
Okay,
You FOIL it.
correct. That's what I have to do here. I can't just say, oh, this is x squared plus 9. I can't just take this and distribute it. I have to use the FOIL method to solve. Did that answer your question?
Yeah.
Okay. So that's actually, I'm really glad that she brought that up. So when we're doing this and we FOIL, we're taking the first part is going to be the square root times its square root. So we'll be left with x plus 1 because those will cancel out. Next up, we're going to take the square root x plus 1 times negative 1. So that'll be negative square root of x plus 1. Negative 1 times that on the inside. So negative square root of x plus 1. And then on the outside, negative 1 times negative 1 is going to become positive 1. Yeah, no problem. I'll back it up.
I'm confused. I second Stella in the fact that I don't.
Okay.
When you multiply the square root, how is that like multiplication?
So if I multiply these two that I just circled, they're both the same exact thing. It's like multiplying the square root of 3 times the square root of 3. How you get just 3. Same concept. So that's just x plus 1. So then when I'll do these color coordinated. When I do this times just a negative 1, it creates the whole thing to be negative.
Okay, but it's still a plus 1.
But it's still a plus 1 inside, but on the outside it's now negative.
Putting 1 in parentheses.
Yes. Yes. Okay, so now the next part. Hold on. So in green, negative 1, and then the square root of x plus 1. So that's negative square root x plus 1 again. And then I'll use blue. Okay, negative 1 and negative 1. That becomes the plus 1 in the back.
Oh, okay. I get it now.
All right. All right, so from here, I'm just going to combine like terms. Do a little CLT. Yeah, little TLC to this using CLT to my math problem. This will be x plus 2 minus 2 square root of x plus 1. I have two radicals that are the same, so I have to add their front numbers together. Negative 1 plus negative 1 gives me that negative 2. Since I now only have one radical, I want to try and start moving things over in order to get it by itself. So I'm going to subtract 2 from both sides and subtract x.
Is the negative 2 part of the radical?
The negative 2 is part of the radical, yeah. So now I've got negative 3 is equal to negative 2 square root of x plus 1. I'm going to divide by negative 2. And I'll end up with 3 halves is equal to the square root of x plus 1. Now square both sides. 9/4 is equal to x plus 1. So then subtract 1 from both sides, and you'll get 5/4 is equal to x. And that should be your answer. Now, to save us some time, I've double-checked this answer already today for most of the classes. It does indeed work when you plug it back into the original equation, but you do want to make sure that you check your work if you get the chance. Well, thanks. I'm recording class, so this is how you give you a heads up. All right, questions at all? Okay, we're going to go to number 4. We're going to skip example 4 right now. I want you to try example 5. Try it on your own. The only thing that I'm going to say is before you do it, add the square root of x over to the other side. You can work with a partner on it. Just remember we are live, so but try it out. Take a couple minutes, see what you can do. Folks at home, if you want to try that as well, you can. Okay. Okay, if you're working through the problem and you want to see it, then yeah. Thank you. All right. Try and FOIL. If you've gotten to that part already, you can definitely do that. Go ahead and just kind of clean things up here a little bit, combine like terms. If you have a question while I'm doing this, I know that some of you are already trying to do it at your seats. Just ask. Very similar to our last problem that we did. You want to try and move everything over from the radical away from it. So we're going to subtract 4 and subtract x. Divide by 4. And then square both sides. Okay. Cool. Good deal. Questions at all? I'll leave this up here for a minute if you're trying to copy it or if you somehow like form a question. We're going to jump to example number 6, and then we're going to jump back to example number 4 for our last one. There's a reason I want to do 4 last. But Yep.
So I understand how you got to 8 over 4 and 4 times square root of x over 4. I don't understand how that ends up being 2 equals square root of x. Like, is it literally just simplifying down? Like, where did you get the square? To do the
the very last step?
Yeah.
So anytime that you have a square root, in order to eliminate it,
you can square. And what I do one side, I do the other. So if I square that eliminates that square root, and then like a 2 squared becomes 2. Can we just
Okay, that makes sense. Thank you.
do this in example 6? You can say what else.
Yeah. If you want to try example 6 on your own, go ahead. But take a look at example number 6. We've got a fourth root. How do you eliminate a fourth root?
4.
4, yeah. Take it to the fourth power. So now I'll subtract 5x from both sides. And I'll get 3 is equal to 0, which isn't true. So this is no solution. All right, questions at all? Yeah, once she gets back. You can ask at the end after this is done. Yeah. Yeah. Hey, what I'd like you to do, actually, is why don't you try real quick? Because I had a student ask if I could scroll to example 3. Actually, I'll scroll at the end. I'll scroll at the very end to it. Follow along with me for example number 4, because example number 4, you can use a calculator on towards the end. So I'm going to add 3x over. So I get 4x plus 2 equals 3x plus 1. I'm going to square both of these. I end up with 4x plus 2 equals 3x plus 1 times 3x plus 1. Okay. So now what I'm going to do from here is I'm going to FOIL that right side. So I've got 4x plus 2 is equal to 9x squared plus 3x plus 3x plus 1. So 4x plus 2 equals 9x squared plus 6x plus 1. Because I have an x squared and I have an x, this is different than any of the other problems that we've done. Most of the time, we usually just start moving things over. But because I have that x squared and that x, I actually have to set everything equal to 0 in this problem. So I'm going to go ahead and do that. I'm going to subtract 4x from both sides and 2. And now I have to think, can I factor? Is there anything that's going to be multiplying to give me 1, multiplying to give me 9, and add somehow to give 2? No. So now I have to use quadratic formula. And this is where you can use your calculator, because there is a calculator portion of your exam for this year. So quadratic formula, x is equal to negative b, so negative 2 plus or minus the square root. So b squared minus 4ac, so 9 times 1, all over, that'll be negative 1, 2a, all right, so x is equal to negative 2 plus or minus the square root of 40 over 18. You will get your calculator for a portion of the exam. This is the type where you would have like that portion. Yeah. All right, so now when I plug this into my calculator, I should have 2 different results. One of those results is going to be negative 0.46. The other result is going to be 0.24. And those will be my answers. Okay. That's it for the notes. Questions at all? I'm going to go ahead. I'm going to shut the live feed off. Those of you at home, thanks for watching.